Hey everybody, here is our next section, or lesson, I guess, on the unit circle trigonometry. So we're slowly making our way towards the unit circle. Today we're going to talk about angles of rotation and then a type of rotational angle, which is called a coterminal angle. And we're going to do this first by labeling this diagram here into standard position, which just means putting everything in the right spot for it to be an angle. We have three things we're going to look at here. We have a vertex, an initial side, and a terminal side. The vertex is going to be the center. The initial side is the fixed ray, the one that doesn't move. That is always going to be on the positive x-axis. Let me label our stuff here. There we go. And then the terminal side is the ray that rotates. It's also where the angle ends. That's why you hear the word terminal. So let's say I gave you a 120-degree angle. You would rotate to about 120. Draw here. That's our terminal side. See, it came right out the center, not out of right here, out of the center. And that's our angle. A lot of times we label it like that right at the end. You're also welcome to label your axes if it would help you. Here is 0 and 360, or 0 and 2 pi. This one here is 90, also called pi halves. This here is 180, also known as pi or 1 pi. And then down at the bottom here, we have 270, also known as 3 pi halves. I am not going to ask you to memorize that. Your life will be easier if you do them. Next, it says positive and negative angles. Your angles, since they're just rotating, can be positive and negative. The thing that can't be positive and negative is a distance and a direction. So looking here, it says the measure of an angle tells us the blank and the blank of rotation. That's going to be distance and magnitude. Magnitude is how far around it goes. So the total rotation. And distance, oh, sorry, I'm a silly goose. Direction. Direction, not distance. I apologize. If it's going in a positive or negative direction. Positive angles have a blank rotation, and negative angles have a blank rotation. So I'm looking here. This one is a positive 120. I already labeled it. And it's positive because I went up this way in the positive direction. If I had gone in the negative direction like that, then I would have put negative. Okay, so looking at our positive or negative, we have positive angles go in a blank direction, sorry, rotation, or negative angles have a blank rotation. If we look, we already have this one graphed right here. This is a positive 120, and we went this way, that direction to get it. We went up in the positive direction. If you think of a clock, right, let's draw a little real quick rough sketch here. Here's a clock. Clocks go this way, right, as they get later, so they go this direction. If I'm going this way, that's the opposite direction of a clock, and that is called counterclockwise. Fun fact that you didn't ask for, if you are in somewhere like the UK, they actually call it anti-clockwise, which is the same thing. You're welcome to use that if you prefer. Negative angles have a blank rotation. So if I look here, if I go in the negative direction, remember negative is down in this negative direction, I would be going this way, which is the direction of a clock. So negative is clockwise. And there we go. So here's our standard form picture, drawing, whatever, of our angle. And then I have some directions here and then some examples on how to do it. First, we're just going to practice actually graphing the angle, not worrying about originally the degrees. We will find the degrees and the radians once we have actually gotten to that point. But first, we're just going to practice doing the actual literal rotations. It is easier when they just give the rotations because you know how far around to go, as opposed to when they gave you, like, let's say they said 70 degrees. You have to actually know where 70 degrees is to stop. So look at number 1. It says graph an angle with 2.75 clockwise rotations. What is the measure of this angle in degrees and in radians? If I look at the directions, it says identify if you're going to rotate up, which is counterclockwise, or down, which is clockwise. This decides if the angle is positive, which goes up, or negative, which goes down. we have 2.75, that's our magnitude. Clockwise, that's our direction. Clockwise goes this way, so we're going down. That means we are negative. And I'm always going to start here on the positive x-axis. There we go. And if I'm going clockwise, I'm going to go 2.7 times around. So if I go one time around, it would look like that. That was one circle. I'm going to go 2.75. I'm going to go a second circle. That is 2 times around. I'm going to go 2.75. And obviously you can see here, like this is a quarter, that's a quarter, that's a quarter, that's a quarter. So 0.75 would just be 3/4. So here is 0.25, there's 0.5, and there's 0.75. You put a little arrow to show which way you're rotating. And then from the center at that vertex, you draw your terminal side to meet your arrow of movement. And this is our angle. If you were to ignore the rotations, this would look like a 90-degree angle, but it's much bigger than 90 degrees, right? Remember, one time around is 360 degrees, and we've gone 2.75 times around. So let's go ahead and figure out our amount here. The size of our angle, what I would do is just multiply my total rotation times how much it is for one rotation. If I'm going in the clockwise direction, which is negative, I would do a negative rotation. So negative 360. Or if I wanted it in radians, I would do total rotation times negative 2 pi, because that's a full rotation in radians. So 2.75 times negative 360. I'm just going to type that in my calculator. And I always want either a whole number or a fraction. I do not want a decimal. This one we have a whole number. It is negative 990 degrees. So very big. And then the other one, let's see. Remember, we don't want a fraction, or sorry, we do want a fraction, we don't want a decimal, so we're not going to put pi in the calculator. That one is guaranteed to give us a decimal. I'm just going to do the numbers here. I'm going to push the fraction button. And it tells me the fraction is negative 11/2. And then I'll just put the pi back on. Like that. So our answer here is negative 11 pi/2. Or you could also say negative 11 pi halves. But let's try number 2. This one's going the other way. So it says graph an angle with 1.5 counterclockwise rotations. Remember, 1.5 is the magnitude, counterclockwise is the direction. Counterclockwise is going up this way, so it's going in the positive direction. Let's go ahead and label that. Here we go. We're always going to start from the center onto the initial side. And I'm going to go 1.5 rotations counterclockwise. So I'm going to go 1 for sure. There's 1. And then a half. There is half right there. Put a little arrow. Remember, your side comes out of the center at that vertex. And then does that. So if you were to ignore the rotations, this would look like just a flat angle, where it's called a straight angle. But it actually goes around 1.5 times. So let's go ahead and see what that would be in degrees. Notice I'm positive this time because we're going in the positive direction. And radians. 1.5 times 360 is first. Let's see what we get. 1.5. Oop, that's a 4.5. That was way too big. 1.5 times 360. That says 540. And then 1.5 times 2, I'm just going to tell you that one's 3. Then I'll put the pi back on. So I got that by doing 1.5 times 2 in the calculator, then stuck pi back on. And there we go. Okay, go ahead and try 3 and 4. And then unpause when you're ready to check them. Here are our 2 answers here. For number 3, here's what our angle looks like. It just looks like a flat line going in the same direction, both the arrows, because you went around exactly 1 time at clockwise, which is negative. You can see here when I multiplied, I did do negative for that purpose. So our angle is a negative 360-degree angle or a negative 2 pi angle. And then for number 4, this one was a little bit more tricky. It was 1/3. What I did personally was figure out, I know this is 0 and 2 pi, right? I know that this is 90 or half of a pi. I know this is pi or 180. I know this is 270 or 3/2 of pi, right? Because this is 1/2, 2/2 or 1, 3/2 or 4/2 or 2. So what I'll do from here was I figured out, okay, well, if that is, here is a quarter and that's a half, that would be 0.5, that's 0.25, and 1/3 is 0.33. So I put it somewhere in this vicinity over here. And that ended up being 120 degrees because 1/3 times 360 is 120, or 2 pi thirds because 1/3 times 2 pi is 2/3. Perfect. Okay. Look at the next page. Get on to the real meat of the information here. We're looking at coterminal angles. Now that you know how to graph an angle, what you're going to do for coterminal angles is you're actually just trying to find two angles that end in the same spot. So they look exactly the same if you weren't going to draw the rotational arrow. If you just were to draw the initial side and the terminal side, they would look identical because they end in the same place. Up at the top here, it says an blank, an angle is formed by rotating the blank of an angle to the desired rotations. The one that moves, remember, is the terminal side. Once an angle is graphed, you can use the terminal side to find the coterminal angle. Remember, co just means share, terminal means end, so share the end side. A pair of coterminal angles is any pair of angles that have their blank sides in the same place. That would be their terminal sides. If you did not draw your blank on the graph, all coterminal angles would look exactly blank as each other. This means they're exactly blank rotations apart. So if we're looking at coterminal sides, they have the same terminal end. If we did not draw the rotations on the graph, here we go, all coterminal angles would look exactly the same as each other. This means they are exactly blank rotations apart. They're exactly whole rotations apart. 1 rotation, 2 rotation, 3 rotation, 4 rotation, because they end in the exact same spots, they have to be rotation. Good. Next, right here, we have these pictures to help you out. We're going to label our quadrants here on these pictures so you can see where coterminal angles stop. So you can see they're all stopped in the same place. Here in quadrant 1, that goes from 0 to 90. Or 90 is also called pi over 2. And then 0 is also a full rotation, so it's 360 and 2 pi. But we're just going to stick with 0 for this one. Leave it there for now. It says angle between 0 and 90, or 0 and pi over 2, or half a pi. Quadrant 2 here starts at 90 and goes to 180. Also known as pi over 2, or half a pi, all the way to 1 whole pi, because 2 halves make a whole. Looking at quadrant 3, we're starting here at 180 degrees. And we go until 270 down here. For radians, we start at pi. Remember, this is a half a pi. That's 1 pi, or 2 halves. And this is 3 halves. So 3 pi over 2. And then last but not least, we have quadrant 4. This is when it makes a full circle around. So it goes here at 270 until 360. And then it can also go, if we're looking at radians, from 3 halves until 4 halves, or just 2, because 4/2 is 2. Good. Hopefully these pictures help you a little bit. Down here at the bottom, we have some examples as well as the steps on how to do this. I'm going to go through the steps first. It says how to find a coterminal angle. You're always going to graph the given angle first. Once you've done that, you're going to look at the quadrant that your terminal side is in. If the angle is greater than 360 or 2 pi, subtract the rotations until you get a new coterminal angle between 0 and 360. Or if your angle is less than 0 or 0 rotations, add them until a new coterminal angle is between 0 and 360. Our goal is finding the specific coterminal that's on the unit circle. Sometimes it is easier, actually, I said step 1, graph it. Sometimes it's easier just to graph it after you already figure out what it is. So looking at number 5, we want a coterminal angle on the unit circle for the angle 720. So we're trying to find an angle that stops in the same spot the 720 does. 720 is too big to be on the unit circle. So we would subtract a rotation, just one at a time, until we got to a number that's between 0 and 360. So 720 minus 360 is actually 360. I'm just going to be your calculator here. So this is on the unit circle, and that is in, technically, it's between quadrant 1 and quadrant 4. We're just going to call it quadrant. Let's go ahead and draw that. There's my initial side. It's positive. I'm going to go in the positive direction. If I went around once, that's my once there. This is what I have left, so then I'll go around a second time. And there we go. So this is 720. If you wanted to graph just the coterminal angle of 360, what you would do, put it in the same spot. Sure, let me put my initial side in the same spot too. And then I would go around once, right? And that would be the coterminal angle of 360. So you can see it looks exactly the same, but it has less rotation. That's the difference. But it ends in the same spot. They both end on the positive x-axis. Okay, let's look at number 6. Number 6 says, find the coterminal angle for 30 pi over 7. I will admit that the pi's are much harder for people normally. I think the problem is they don't know how big one rotation is. We know a rotation in degrees is 0 to 360, and we know it's from 0 to 2 pi, right? One rotation is 0 to 2 pi. The problem is we don't know how big this is compared to 2. So what it would help to do, in my opinion, is to write one rotation in the size of your fraction. So our rotation is still going to start at 0. I want to know how much 2 is compared to sevenths, right? If I want to know how many sevenths is equal to 2, like the whole number 2. So to make them have the same bottom, we would just multiply by 7. And that will show me that I have 14 over 7 will be 2. So this is one rotation as well. Now we can see, so if you look at ours, this is obviously way too big to be on the unit circle, right? So I'm just going to subtract a rotation because it's too big. 30 pi over 7 minus one rotation is 2 pi, or we could put 14 over 7. Remember to subtract fractions. We just keep the bottom the same and subtract across the top. 30 minus 14 is 16. Now I'm here. This is my new angle. That is still bigger than a rotation, so we're going to do it again. Remember, we keep the bottom the same. And across the top, we have 16 minus 14 is 2. So this is my new angle here. This is our coterminal angle. I am going to graph both, though. So let's graph the big one. Actually, let's do the small one first. We'll do it in black because I have it in black already. Here's the starting point. There's my initial side. The problem is I don't know how big stuff is, right? I know this is 0. I know this is 2 pi, also known as 14 sevenths. Half of that would be 1 pi, which would also be called 7/7, right? Because 7 divided by 7 is 1, just like 14 divided by 7 is 2. So if I have 2 pi's, if I know this is 0, I know this is 7, I know this is 14 over 7, 2 is going to be somewhere in here. And I know that because if this is 0 and that's 7, that means halfway. This would have to be 3.5 sevens. So 2's got to be somewhere in here. Let's go like there. There we go. Perfect. That's the coterm. And let's do I'm going to do a different color here for the 30 pi over 7. If I did 30 pi over 7, let's see. We know 1 rotation. We know that was 7 over 7. Oh, sorry. 14 over 7. My bad, because we went 2 pi's is the rotation. If I went again, there we go. That would be this one and this one. So that's my 2 rotations. I still have 2 pi over 7 left. So I would go the rest of the way right there, and that would end me here. So you can see how they end in the same spot, but they look completely different, right? One of them is a bunch more rotations than the other one. And that's how you do it. Go ahead and see if you can figure out the other two. They are too small, so you're going to have to add rotations instead of subtract them. So go ahead and pause, try 7 and 8, and then come back when you're ready. Here are these bottom two. I realized I forgot to have us write it as a sentence. I want to do that for the first ones as well. So we'll go back and add that on. But number 7, you should have gotten 220 degrees. You were at negative 500, and it was way too small to be on the unit circle between 0 and 360. So I added a rotation that got me to negative 140, still too small, not between 0 and positive 360. So I added another rotation, and that got me to 220. I did color code. You can see here my graph if you want to look at that. You can see the negative 500 had more rotations than the 220 did. And then for number 8, we were at negative 2 pi over 3. Here is how much it is for 1 rotation. The reason we're showing this part is just because it's a lot easier to understand where your stuff is on the graph if you know how big 1 rotation is. We know that a rotation is 2 pi. And if I want to do thirds, 6/3 is 2, because 6 divided by 3 is 2. That's why. So I know here this is too small because it was negative. So I added a rotation. And then remember, when you're adding fractions, you just add across the top if the bottom is the same. So negative 2 plus 6 is 4. And that is between 0 and 6/3. So I kept that one. And then to graph, I did the original angle in pink. You can see it goes a different direction, right? It was a negative, and then the blue one is a positive. But they both end right here. And then for the other two, let's just add that sentence on. We're going to say 360 is coterminal to 720. There we go. And then this last one here, we had 2 pi sevenths is coterminal to 30 pi sevenths. And there we go. Perfect. I hope this helped. You have a wonderful day. See you later. Bye.